Right, a pilot is to fly a plane to a destination which is 450 kilometers from his present position in a direction north 20 west. There's a wind from the east at 22 kilometers per hour, and the plane has an airspeed of 300 kilometers per hour. Determine the direction the plane should head to reach the destination. Okay, let's first identify what we've got. So we've got a plane, we've got wind, and we've got some observer who's or the earth or some sort of a fixed point to figure out the direction it should be heading in. So our observer maybe. Okay, so let's call our plane A. We can call our wind B, and we'll call this our C, because we know that our velocity of our plane relative to our observer or to Earth is going to be the velocity of our plane relative to the wind plus the velocity of the wind relative to our observer. All right, so let's have a look and see if we can figure out what's happening where. So the plane has to fly to a destination 450 k's on a direction of north 20 west. So let's put our I and our J component reference axis in, and we know that north, south, east, west is, well, north is in that direction. All right, so he's flying 450 north 20 west, 20 degrees west of north is somewhere over there, and that's a 20-degree angle, and that place is 450 kilometers away. All right, so that's where he wants to end up. But the wind is blowing from the east. So wind is named by the direction from which it blows. So if it's blowing from the east, it's blowing towards the west. So what we've got is a wind blowing like that at 22 kilometers per hour. So that means if the aeroplane went on our original direct track, the wind would blow it off track. So actually what needs to happen is the aeroplane needs to travel over here at this angle so that the wind can blow it into the point where we are wanting to get to. All right, so the wind's also acting on this aeroplane. All right, so something else you need to know is that the word airspeed is the speed of the aeroplane, so the speed of plane relative to the wind. Okay, so that's going to be our A relative to B. Okay, and that's how fast it can go. So it's going to be heading at 300 k's an hour relative to the wind in that direction. All right, let's do some definitions here. So we're going to actually I'll do it up here. Let A be my velocity of A relative to the wind. So B, which will be my velocity of the plane relative to the wind. So that's my wind speed. Okay. My B, well, that's going to have to be my velocity of the wind. So here's my A. My B is going to be my velocity of the wind relative to my observer. And that's going to be my velocity of the wind relative to the observer. And C is going to be my velocity of A relative to C, which is my velocity of the plane relative to my observer. That's what I'm actually looking for. All right. Now I need to work with my angles, and I need to resolve my vectors into I and j components. The easiest one is my vector b, because that's just heading in a negative I direction. So let's start with b. It's the easiest one, negative 22i. And my a, well, I don't know what angle that's acting at, but that's okay. I've got an angle theta, and I have some trig ratios. So I can say that A is going to be, well, I've got a sine ratio, it's a negative I, so negative 300 sine of theta I, and I've got a positive j, so plus 300 cos of theta j. All right. And well, I don't know what speed this thing's going to end up at. Okay, so and I have to call this one C. So let's see what C can be. Well, C, I know I've got an angle of 20 degrees. I don't know how fast it's going, so we'll just call it C. And again, I've got a sine ratio for my, and it's a negative C sine of 20 degrees I plus C cos of 20 degrees J. Okay, and I know that C has to equal A plus B. So I then now know that my negative C sine of 20 degrees I plus C cos of 20 degrees J is going to be equal to negative 300 sine of theta I. And I know it feels like we've got too many unknowns, but just follow the process. It will be fine. Minus 22i. All right, let's equate our I and j components. We can collect them. So that's minus C sine of 20i plus C cos of 20j. And I can collect these, negative 300 sine of theta minus 22i plus 300 cos of theta j. And I can equate my I and j components. And I'm going to end up with a simultaneous equation. So negative C sine of 20 degrees equals negative 300 sine of theta minus 22. And maybe I want to just rearrange that so that I've got it all just in terms of C. So C is going to be 300 sine of theta plus 22 divided by sine of 20 degrees. Let's make that equation 1. And if I equate my j components, I'm going to have C cos of 20 degrees is 300 cos of theta. And so C will be 300 cos of theta over cos of 20 degrees. And let's make that equation 2. So now, if I substitute 1 into 2, what I get is that 300 sine of theta plus 22 over sine of 20 degrees is equal to 300 cos of theta over cos of 20 degrees. Now, we definitely cannot do that tech-free. So we're going to use Solven on our calculator. And it's important when you're using Solven that you use the following notation, okay, it makes sense to give it a range to solve for. Okay, now we know that the angle we're looking for, this theta, is less than 20 degrees. So let's tell our calculator to only look for angles that are less than 20 degrees. Okay, so it's going to look a little bit like this. Solve n, bracket, your two equations equal to each other, and then you tell it what variable you're working with and the range of logical values, so between 0 and 20. So that's my angle size that makes sense, and that's my variable. And what I end up with is theta is 16.05 degrees. But that's not a bearing, okay? The bearing I'm looking for will have to be 316 minus, because bearing is clockwise, measured clockwise from north. Okay, so therefore the true bearing is going to be 360 degrees minus the 16.05 degrees, and that will be 343.95 degrees. Okay, so basically what that's saying is the plane should head on a bearing of about 344 degrees true.